Hello everyone, we are going to start the class. Just let me know when if anybody is not able to see the screen. Okay, so in the last classes we have seen how to install the Hadoop and how HDFS works. Today we are going to see what is how execution environment of Hadoop is there, and on top of it We will see some of the HDFS commands. So today's aims are learning about execution environments and limitations of MapReduce framework 1 and new frameworks like Yarn and what they will contribute towards it in improving. Yeah, so this is what we are going to learn today. So HDFS we have seen last class. It's a distributed file system, and we'll see today MapReduce, our execution environment. So if we recall the previous ones, so data is distributed across the nodes in the HDFS, like all the name nodes. So for example, block 1 is there, block 1 is replicated everywhere in 3, replication 3 is there. So the main block 1 first copied on, for example, node 1, other two are copied in node 2, node 3, like that. We will maintain 3 different replicas of same thing. So here mainly workhorse is data node, so we will keep all the data on data node, and also we'll do computation task on that particular data. So wherever the data is there, there we will create task and run on top of the data. So okay, so it is a software framework, operative execution environment, and it will schedules, monitors, and manages the task. So how it will do, that we are going to see. So the execution environment will work on top of HDFS. So whenever request comes for any processing request, this framework will take care of that. and it will schedules and monitors and manages the task. So as part of this, it will divide the big job into tasks, and it will then schedules, and it will see the progress of that. Eventually it will report to the client whether the particular task is done or not. So usually in any application in Hadoop, MapReduce framework has these phases. Data will be there. On top of data, we will run map, and in between sort and shuffle will be there, and then reduce, then output. So something like this. Input, mapper, sort and shuffle, then reduce, then output. Both input and output are block oriented. So they will be stored in blocks or read in blocks. So in this application, so D1 and D1 to Dn are the data nodes, data, so which is coming from n different sources. So for all the Dn nodes or Dn data, we'll have n number of mappers which will run parallelly. Then sort and shuffle will run on top of them locally to mappers, and then shuffle will happen to put the data for reduce operation, and reduce will be done as aggregatively and we'll get the output. So what kind of programming is this? So what is MapReduce? So it is two level distributed processing framework, and one is mapper, that is record level operation, and reducer aggregatory level operation. Aggregate or group level operation. So for example, we want to count number of users every country. So we'll do in the mapper user ID and map, one for counting. Then sorting will happen on the key. So key is here. We can no need of user ID also. So we can extract country comma 1 from every record, and then reducer just to count. So this is in this way it will work. That means everything can be achieved through the two-step process, and both should be distributed. That means if any program is we are unable to break it into steps, then we can't achieve through the map reduce. So usually some of the programs will be dependent on the some of the other values of previous call. So those kind of things won't work here. Like iterative calls which are dependent on the previous input. So except these, for all other type of applications we can run the MapReduce. I think everybody knows about interactive data exploration and iterative data processing. So interactive is dependent on the input. And since we are running n number of things at a time, we can't dependent on the input. And iterative, which is based on the previous output of the program. So for example, calculating the um, prime number of highest level, then we will definitely has to go through the previous just immediate prime number to find it out whether the particular number is prime or not. In that case, it is iterative algorithm. So graph processing algorithms are there which are very much iterative, and some of the sorting algorithms. So for all these we can't so all the dynamic programming algorithms also iterative. So for all these we can't use the map reduce. So we have higher level frameworks also in Hadoop. Those are Aeon, Tej and Spark, which supports the complex directed acyclic graphs of tasks. So there is no linearity anymore. So that means one job after one job. We can design any number of jobs, so which are parallel, and then merging of output at one point, and again it will be go that particular output will go to input of many other programs again it could merge. So on and so on. That is the DAG. So multiple inputs will be going to the same one process, and one process is putting the output or giving the output to multiple processes. So though if those kind of things are involved, then it it will become a graph. Unlike linear, one input will become output to input to one other program. And also in-memory caching of data with these frameworks, which will increase the performance of MapReduce. So this is the execution frameworks looks like. So HDFS will be there at the lowest bottom, and an execution environment called yarn will be there. On top of it, we can run the MapReduce jobs. So on top of like T is a processing engine, Spark is also a processing engine, and MapReduce works on top of the Tej, and Pig Hive also works on top of it. And Spark, we have Spark mlib and other Spark SQL and other things. So with the Spark specialties, it can run without even yarn. So Hive is supported both in Tej and Spark. So yarn is a MapReduce processing engine basically, and it is developed. Later, all other applications are getting used. So it is an execution framework. So Tej is a data flow graphs, and it can run the complex DAGs of tasks. It is mainly used for the Hive and Pig, where more number of tasks will be there, and DAG of tasks has to be handled. So this is one of the example. So this is how a Hive example, like one select query will be resulted into multiple mappers and reducer. So first set is select, that is mapper, and then reducer, and join is again reducer, one more join, and one more select is coming parallelly, which is a mapper and reducer, and another mapper, and then we will join. So both the mapped outputs will join at the reducer. So what is the difference between the normal MapReduce and Tej is wherever the HDFS is there, that means after every step it is processing, but in Tej it is not processing until the end. So first it will design the all the tasks, and then it will do the processing at a time. That's why we are able to remove all the IO here, only one time IO. So Spark is advanced DAG execution engine, supports the cyclic data flow, and very important, that is in-memory computation, and it supports multiple languages like Java, Scala, Python, and R, and all the libraries are optimized, very much optimized. So we can use all the frameworks. So scheduling will be done first compass so our capacity to all these kind of different algorithms. So what is mainly resource scheduling is the where exactly JVM has to run and how many instances, how much memory has to be given for every task. So the main thing will go like this. So whenever any mapper or reducer, so JVM instance creation and memory allocation. So this is a resource, and then scheduling the things, schedule the job and tracking of it, tracking the progress. Informing the client about the status. So different kinds of algorithms are there, parameters can be controlled. So here schedulers has its own role to play in all the execution engines, and how to control the resources is another point of conflict here. So how it differs from MapReduce 1 to 2. So these are the three different schedulers. The default one is first in, first out. This is very famous, we know that. So whichever job comes, we'll give the resources to it. And for example, first in, first out will fail uh, when a bigger job comes later on. The first two jobs are small jobs, and bigger job comes later on. Or if bigger job comes beginning, and then no resources will be there for the remaining jobs. So to come out of this problem, we have two other things, like that is fair share, mainly for if we want to run as many possible jobs, then it will be better to go with the fair share. That means 100% or majority is not given to one particular thing. So share wise, depending on how much resources it requires, all the jobs will be given. And capacity, this is little modified version, depending upon the depending upon the capacity of particular thing. a particular server might have huge capacity. Then we will schedule more jobs or more tasks to it, and a particular other server is less capable, then we will schedule less number of tasks to that particular server. So completely depending upon the capacity. So fair share is better because we run on the similar hardware. So capacity will work, but it is it is possible that most of the systems are identical in resources. So capacity scheduler will look like this. Sorry. So these are different nodes. Node 1, node 2, node 3, node 4. What does it mean? So node 4 has highest capacity, followed by 2, 1 and 3. So that's why we have given in such a way to make use of these particular capacities. We take care of capacity scheduler by queuing system and ACLs. So fair share scheduling. So the basic difference here and there it is, that is the machine, or it is based on the resources oriented. Here it is application oriented. So there, depending on the resources capacity, we are scheduling accordingly. Here it is based on the application we are scheduling. So how much things are required for app 1, that is the fair share. So before app 2 got submitted, all the 100% is with the app 1. Once it is submitted, we got the share decreased to 75%, and then it decreased to 50%. So and in the end it is 33%. That means every app submitted is getting the some share in scheduler. That means all other processes are not waiting for app 1 to be completed. So it is very good in the sense it will be very interactive and progress will be seen by user very quickly. So this is mainly balancing between the apps, and queue system will be there. So limits per user or app, and it is a weighted app priorities. You can set the priority for particular app, and the limits per user will be there. So a users apps won't run after some number is reached. For example, we could set 5 as a limit. So from particular user, he can't run more than 5 at a time. Everything else will go into the queue. So queue system. So Uh, so what is this? Basically, scheduling the apps and running them on the execution environment. So default is first in, first out, and two other schedulers are there. Those are fair share and capacity. So what is the main difference? The difference is one is the resource oriented, another one is app oriented, which is more balanced. So capacity is resource oriented and fair share is app oriented. So queues and subqueues are possible. We can set the quota of every user, how many apps, and resource limitations. We can put the resource limit for every user. And apart from these three, we can route our own schedulers. So this is it. Now we will see some of the Hadoop commands. I think everybody has their system with them. So any doubts until now? You people can type whatever doubt. Hi guys, is it fine? Everything? Okay. Arun and Kim, you people are getting. Yeah. Everybody, we can go forward with the Hadoop commands. So we can see we have so many Hadoop commands. So basically Hadoop commands can be divided into two level commands. One is file system commands and second is admin commands. So all the file system commands will start with Hadoop fs or hdfs, dfs like this. So the mainly here what we can do, So how to download the data from Hadoop file system? How to copy? First thing is how to copy data to HDFS, and how to download data from HDFS. So we can do it in two ways, that is put and get commands, and also copy from local, copy to local. So first we will see how to copy data to HDFS. That is the put command. So it look like this. Or we can use copy from local. Okay, both will work fine. Or we can do one more thing, that is append to file. So in these three ways we can copy the data to Hadoop. So I'm just starting the virtual machine, Hadoop virtual machine. Is any one of you has not installed the Hadoop machine? Everybody installed, right? So okay, it is working fine, I hope. Okay, okay, in the meantime we'll see some other HDFS commands. So how we can download data from HDFS, that is getting the data. So two ways, that is get command and copy to local. So it just started. No. Okay, no issues. So this is the basic thing we can do after just getting the files, that is ls. So ls is list, and after that we can see whether we can copy the data to HDFS. We can copy in these three ways, and then again downloading from the HDFS. So apart from this, we can copy the data. So slash is a root directory, and we have count. So we can just count what are the number of files. So it will be helpful just like list command, and we can use the fsck file system check, and also balancing tool, that is Hadoop balancer. So we can run most of the Unix commands here. So that is like making the directory, copying the directory, move command mv, and cat to see the data. And just pinging some of the commands. Just you will I will just send it to the your email IDs, but just for the sake of doing it right now, you can do it. So we have some. So we can go and check. So from here we can go to shell. Okay, so we can go to any shell. So we just do ls. Okay, so these are the different files. Or we can connect to putty. So we have so many commands. You can see here. We can make use of any one of them. So this is cat checksum. These are the permissions. we can change everything. So copy from local, copy to local, count CP, and the disk usage difference, get, make directory. So I'm just copying and pasting it here just to see are there. So this is the HDFS FS command line, and in the same way we have HDFS DFS. This is supported from so same set of the commands. Either we can use it the HDFS DFS format or Hadoop FS. Similar way, just Hadoop has these many options. That is, we can go to admin, that is fs command, versioning, jar, and so previously we have admin here, but now it is deprecated. Everything is done differently. So we'll see the version. So this is the version. So we are using Hadoop 2.4.0 and Hadoop Commons, same version. So to copy, we can do one thing, that is so I just did this after creating. Now I will see whether this particular file is there or not. So this is the files, different files. Any doubts in using the Hadoop file commands? At least some of you people are able to test some of the commands. Yes, no. So you people test these also? No, along with these commands. So we can create locally and then we can do put command. So if no file is there, then it's a problem. So we can create it by doing like this cat and whatever the text name. And then we'll go with the insert mode. Then whatever we want to type, we'll type. Then we can come out with the colon Q. So colon Q exclamation will do quitting of the particular VIAT. So it will go like this: viabc.txt and cat we can't do in the beginning. Once it is done, we can do cat. So like this we can create some of the files and we can do that. So from the file browser also we can do all the file operations like uploading the files, downloading the files and deleting, changing the permissions. For example, I have this particular file. I can select. So what I can do with the file? I can rename, move, copy, change permissions, download and delete. So this is the file. So we can do anything, like if we want to delete particular thing, we can go and delete the file in two ways. One is move to trash and delete forever. can change the permissions like this and submit. And also I can rename, I can delete. So it is always better to do forever. So now there is no scala.txt. So from the command line, whatever we can do it visually here. So by using this, we can upload the files. So this is a file. So we can change the permissions on this once we got the file. So like this, I can do it visually. Even we can create one like sample or with my name. Okay. So I can edit this file like this. And save and come back. For example, I want to see these files. So they are in user view. I can go to them in backend. So by like this, Hadoop FS. So these are the different files over there. We can see some of them per se. So instead of ls, I can do count. So count will give you number of files in that particular folder. So it will do kind of recursive. There are 49 and 63. And we can do head and tail are there in Unix. So we can do tail command. With the file called so tail will give you last records, last 10 records by default. Any doubts in these commands? So this is the content within that file. So this is like, so tail command, and we have count also. So we can practice a number of commands. So most of them are like, for example, du command is there for disk usage. We can go like this for the same. So disk usage will tell you how many bytes it is occupying. And we can change the permissions. We can create the directory. We can remove the directory. Okay, one interesting command is there, that is, we want to know whether the particular file is there or not. So by using the test command we can do that. That is Hadoop fs test. So this particular test will give you true or false kind of result. So it won't give anything on the output, but it can be used inside the shell scripts. So there we can just check whether the particular file is there or not. Not there, we can create it. Sorry. So I'm open for doubts. Okay guys, if no doubts, that is the ending of the session. We'll see you tomorrow at the same time, and I will be mailing you people right away. So this is the way to go to Hue, a file browser. That's all.